Hello, everyone. Thank you so much for tuning in. We're going to talk about AWS Cognito as a solution for authentication and authorization. Then we're going to mainly go over a few common security misconfigurations that can affect its implementation. I've chosen this topic because I've seen how easy it is to misconfigure it, as well as the fact that a lot of people, especially bug hunters, think it's difficult to test, whereas it really is not, as long as you just understands how it works. Before we get into it, let me introduce myself for those who do not know me. My name is Yassine Aboukir. I'm originally from Morocco. I'm based in France. I've got a decade of experience in application security consulting. I work with companies to provide them with pen test, security assessment services, and that in similar regards, this year I joined HackerContent pen test program, and I've been working with their clients as well. So I've been doing bug bounties for a very long time, probably since late 2013, early 2014 to be accurate. I mainly hack on HackerOne platform where I'm currently ranking in the top 20. So this year I've been fortunate. I earned the most valuable hacker, the InVeach title, and the first place at a live hacking event that took place in Denver. As you can see in the picture in the right, that's me holding the belt, looking like a UFC fighter there. From 2017 to 2019, I had the chance to work for HackerOne as a part of the triage team. It was a great experience. And I also love traveling and been doing it for a couple of years now as a digital nomad, just hacking from different places. Yeah, that's it. So let's get into it. Introduction to AWS Cognito. If you've got any developer background, you know that user authentication and authorization can be quite challenging when you're building a web and mobile app. So the challenges include handling just user data, passwords, token-based authentication, and managing permissions, scalability, federation, etc. So it is pretty easy to mess things up, especially with authentications, which is quite sensitive. So Amazon Cognito offers like a scalable and complete solution to add a sign up and assigning features to your application. It provides identity federation, makes just implementing security easier as long as you're just careful with how you're configuring it. So Cognito allows not only managing authentication, but it also provides a way to manage authorization, user permissions, which are usually time and resources consuming to properly build. So when we talk about Cognito, there are two main components or say concepts to distinguish. First one is the user pool. So when you're setting up Cognito, you create the user pool, and the user pool here allows authentication, basically sign in and sign up. And then we have the identity pool. It is used for authorization to allow users to use various AWS resources such as Amazon DynamoDB, Amazon S3, API gateway, etc. So these are the two main concepts to remember. This is the architectural diagram that reflects a high-level authentication and authorization flow. So basically, you have the user that authenticates to their account. So when they're authenticated to their account, they're checked against a user pool here, and then the user pool will generate and return three GWT tokens: ID access, refresh token, the ID token, the access token, and the refresh token. And then the ID token is passed to the identity pool. The user then will receive a temporary credentials with permissions that are based on the EAM role that was mapped to the group that the user belongs to. So the user can then make calls to various AWS services based on their role permissions assigned to their credentials. In this case, they can access the DynamoDB with the AWS credentials, as you can see there. Right. The question is how you can tell if an application is actually using Amazon Cognito. So when you're doing the testing, it's pretty easy. Like if you're using the web proxy, for example, Burp Suite, you can just see that there are some API calls to Cognito endpoint here. There are two different ones. The yellow one is the request that is being made or being sent to the user pool, as we mentioned before, when you're authenticating to your account. The green one is sent after authentication to identity pool, to exchange, basically to exchange the ID token into a temporary AWS credential, as we previously mentioned in the diagram earlier. So I've been personally playing with AWS Cognito and exploring various security configurations in the console, and I've concluded that it's quite far easier to mess things up, as there are too many features and security configurations that could confuse any developer. Uh, I've also came across a lot of these security misconfigurations, both while doing back bounties and penetration testing, so they're actually very common to find. Oh, okay, we're gonna start with the first one. The very first security misconfiguration is when the temporary AWS credentials are over permissive, liberal credentials, in a sense that they unintentionally allow access to or they give you access to or manipulate other sensitive AWS services. This is especially bad when unauthenticated roles are enabled, as anyone without having an access to an account could generate these temporary credentials and just gain unauthorized access to these AWS services. So assuming we're not authenticated and we do not have access to an account, there is a huge chance unauthenticated roles are enabled in the console by the developer. So we basically just need to find the identity pool ID and the AWS region, which mostly are like over 80% of the time, they're just hard coded somewhere in the source code or in a JS file. So this is the example here, as you can see below, of a back bounty target I was hacking on, and I was able to find these pieces of information in a JS file that was being loaded by the app. So it is mainly the user pool ID, the client ID, the region, and the identity pool ID. The latter is what we're actually interested in. So you can just use Burp Suite to search for the following keywords in order to find the identity pool ID. But remember that the disclosure of this ID is not necessarily an issue or a security misconfiguration, as long as the backend is properly configured, right? Okay, so after I find the identity ID in the JS file or in the source code, you can use or download the AWS client, which is widely used, and just configure it. Then you can simply run the command, the AWS command, as you can see there in the green, with the after replacing the pool identity ID and the region. So after you execute the command, it will generate an identity ID. This is different from the pool identity ID, just the same name. So it will generate an identity ID that you can see in the screenshot there. And then you'll just have to copy the identity ID that was generated and execute the next command here in the green. And this will generate temporary AWS credentials for you. So this will generate an access key ID, the secret key, and the session token. Now we will check if these credentials, the generated credentials for this unauthenticated role, have any liberal permissions that would allow further access to the app or to their AWS services. There are mainly two tools that I recommend and I use. The first one is Enumerate AI. This one is pretty easy to use and quite minimalistic, as it allows enumerating these permissions. There is also a comprehensive one called Scout Suite. This one is more comprehensive and does the same thing. You can check their GitHub repository on how you can configure it. But in this screenshot, I mainly used Enumerate AI and managed to enumerate some permissions associated with the credential that we generated. But in this screenshot, nothing really was interesting. I don't have any screenshots of like sensitive services that I've had success with, unfortunately. But as you can see, the idea is the same. We enumerated some permissions like the git caller identity. This one is not interesting, and the dynamo describe endpoint. Both are not interesting. They just return some details. First one, details about the user or role that is being used. And the second one is just the returns details about the endpoints of the current AWS region. So uh, so yeah, unfortunately, I don't have any screenshot for other sensitive permissions, but in the past, I've seen credentials with access to S3 bucket, Lambda functions even, and access to DynamoDB tables and etc. There are so many things that might go wrong. All right, so there is a chance that the unauthenticated role is explicitly disabled in the console. So in that case, when you attempt to generate an identity ID, like in the previous step, it will actually throw the following error. Unauthenticated access is not supported for this identity pool. But later in the talk, I'll show you another misconfiguration that you may actually leverage to opt in and to get an account on an application that does not provide any user sign up or registration. So just be patient. All right. So in that case, assuming that you do have an access to an authenticated account, once you log into your account, just keep an eye out for this API call that is exchanging the ID token. As you can see in this screenshot, it is exchanging the ID token into temporary AWS credentials. Similarly, you can just use the tools that I've shown you to fetch the permissions associated with these credentials and see if it allows any further access to their AWS services. All right, let's get to the second misconfiguration. The second one is when the application does not allow sign up or any self registration. Let's say you have a SaaS app or an admin portal for which user provision is only done by an administrator. They might not have implemented any public sign up, for example, but they have left the sign up API action enabled in the AWS console, which is misconfiguration. Uh, so from my personal experience, sign up is always enabled by default when creating a user pool in the console. So unless you explicitly disable it, an attacker can leverage the Cognito API endpoint in order to sign up and provision an account for themselves. How we can do that? So to do that, to test against this particular misconfiguration, you will need the application client ID, which is usually hard coded in the source code as we've seen before. And also you need the client ID, which is usually sent over to Cognito API when you try to log in to your account. So it's easier to find, just use Burp Suite. Then you will simply next send an API call to sign up with your email address using the AWS client, of course. If the sign up is left enabled, misconfigured, then you should receive a 6-digit code to your email address that you used for sign up. So, but as you can see here, in the screenshot here, this is a failed sign up below, but in the middle, you can see a successful sign up that says that we should receive a code to our email. So, oh, by the way, if you don't want to use AWS client, you can always send just direct HTTP call to Cognito API endpoint as follow, as you can see here in the screenshot. So this is just a replacement if you don't want to use AWS client. You can construct this HTTP request. Make sure you're using the appropriate HTTP header for sign up here, as you can see, and the body is properly formatted in JSON. So this is exactly the same as using AWS client. I prefer the AWS client, to be honest. It's pretty easy. All right. So if the email verification is also enabled, you won't be able to access the account unless you confirm it. But that is quite easy. So you can again leverage AWS client again by simply providing the email address, the client ID, the region, and the 6 digits that you received in the email. Once you hit enter, it will confirm your account. So it's pretty easy to confirm it. That's not a problem. Sometimes you might be able to sign up. You get an account, but it doesn't have any role assigned to it. Unfortunately, that could happen. But there is a chance that uh, uh, well, so oh sorry, this is the So basically, if you want to confirm your account, you can also use the HTTP request here. So what I was saying earlier is that there is a chance that sometimes when you sign up, the user doesn't have any group assigned. So you will not get any access to the application features or functionalities. But in this particular case, you can still use the generated credentials and test them against liberal permissions, as we've seen in the first misconfiguration. All right, the third misconfiguration. Another prominent one is that you can come across writable sensitive user attributes. So basically, when you create a user pool in the console, it allows you to set up a number of standard user attributes, such as email, full name, birthday, phone number, etc. These are supported by default, and these attributes are usually writable, which means that the user can update them at any given time. However, the developer has the ability to create custom user attributes, as you can see here. You can create custom attributes like the user role. It's a custom attribute that I'm creating here in the screenshot to store the role and level of access of the user, which they are supposed to have. But what can go wrong here? A lot, actually. So the security issue is that developers often forget to set sensitive user attributes as readable only. So they leave them as writable, which means that even if the application does not allow the user to change its value, they can always leverage the Cognito API to update it, as we've seen in earlier examples. So a lot can go wrong since the user can update their role, for example, to an admin or change their membership status, or etc. Depends. All right, so how we can do that, how we can update the user attribute. So the first step is to fetch the current user's attribute and see if there are any custom ones that they are not supposed to update. So once you're logged into your account, you will obtain an access token, as you can see here in the authorization header. Then you can just copy it and simply execute the AWS command to get the user attributes. It will look something like this in the screenshot. So you can see all the user attributes that are supported, your own, you can see your own information there. So apart from the standard ones, always look for the attributes that start with the word custom. Okay, so you can also directly call the Cognito API if you don't want to use the AWS client to fetch the user attributes. So you want to look out for attributes that start with custom, as I mentioned. Example of custom attributes that I've come across personally are like custom is admin, user role is active, is approved, access level, and these are all sensitive as they control the user level of access most of the time. And naturally, the next step is to try to update these attributes and see if they are only readable or also left as writable, which is bad. So you can use the AWS commands as posted there, or you can just use the HTTP request to update it. So if if it succeeds, you will get a 200 OK status. Here we try to update the user role from a standard one to an admin. So change the value to admin. And funny story, just when my talk was actually announced, I had someone from the bug bounty community reach out and share a critical bug that they found just exactly by updating their user role to super admin. So basically, they found in the JS file that there is a role called super admin, right? And they just hit the API Cognito, as you can see in the message here, to update their role to a super admin. And luckily enough, they just became the admin of the platform. So this is pretty common in bug bounties, and even when you're doing penetration testing as well, it's pretty common. The last one, the fourth misconfiguration I've come across is when the application doesn't allow updating the email address, as you can see here in the screenshot. But there are both client and even server-side checks, but it is always again possible to change it through the API Cognito. So you just need to get your own access token when you're logged into your account, and then execute the AWS command to set a new email address. So you can always change it using the API, Cognito API. So there are some applications that do not really require email verification because they do not expect the user to be able to change it in the first place. So this can be done from the AWS console, as you can see. And for apps that rely on email domain for granting the user special permissions or access, this will definitely bypass the check controls and result in a privilege escalation. It's pretty easy. So even when email verification is indeed required, like a lot of applications do actually require verification, there's another problem that arises is that the email attribute value, as you can see here, is already changed and set to the new unverified email address. So although the email verified attribute does say that the email is not confirmed here, it says false, but the best security practice is just to never update the email until the user verifies it. So what I've noticed with Cognito is that the user would successfully still be able to log in with the unverified email address. So if the application is not checking the email verified attribute, this will definitely result in privilege escalation. It's pretty easy. So you should always check the email verified if it's set to true or false. For this particular reason, AWS, they recently introduced a new security configuration, which is unfortunately not enabled by default, and understanding its use is still confusing to most people. So basically, if you enable this security feature, the email attribute will not be updated until the user has verified it, which is the way to go. But most applications still have it disabled, especially because it's new, the configuration is new, and just still not enabled by default from my experience, from what I've seen. So we'll take this report on HackerOne, it's public report, as a quick case study, just to illustrate these misconfigurations that I just mentioned. So the researcher here was able to achieve a full account takeover on Flickr, which is I think it's a Yahoo acquisition. So just by abusing Cognito, and they paid him 7.5K just for it being a critical bug. So I tried to summarize everything in this slide here. So basically, we have our victim user with the email jack@domain.com. So Flickr app was not allowing email updates, was not allowing user to change their email, but the researcher, as I told you before, he managed to change it just using the Cognito API. It doesn't matter if there is like a client or server side checks, as long as you can always use the Cognito API as demonstrated earlier. So they updated their email to jack@domain.com, but notice that Jack with a capital J, which is the same email as our victim, but with a capital J. Remember that. So here, there are two misconfigurations. First one is that the email address attribute was left writable. It was left with a writable permission in the console. So it did not matter if it was disabled in the app, since you can always update it from the Cognito API. And the email, second one is the email was left case sensitive, which they could have changed to insensitive in the console. So those were two misconfigurations. Then the researcher managed to successfully log in with the unverified email. They have not verified the email, but they still managed to log in with it. So two issues arise. One is the email verified attribute was not checked if it was set to true. And the second one is the previous security configuration was not enabled either. So otherwise, if they enabled the previous security configuration I mentioned, the email value wouldn't have been updated until the user verified it. So the last piece of the puzzle was the fact that there was an email normalization happening at the application level. So the capital J was changed to smaller j. So the email matched the victim's email, and the attacker was just able to log into the victim's account easily. As you can see, it is pretty easy to mess up things when you're configuring Cognito. So it's very important to be very careful. So here I have some recommendations for developers. Based on what I've seen so far, these are some recommendations. Always remove sensitive details from server responses. Any unnecessary details, just remove it. If you're not using sign up, if it's not needed, disable it in the console as well. Make sure you disable unauthenticated roles if they're not required. Always review the permissions that are associated with the authenticated and unauthenticated role, and always ensure the least privilege access, that like always grant the user minimum privilege access. And then evaluate all the user attributes, and if they do not need to be updated, disable the writing permission if not necessary. And remember that the email claim, the email attribute, can always hold an unverified email address, as we've seen in the report that we just mentioned. So that's it. Thank you so much for tuning in. Appreciate it. Reach out on Twitter if you have any questions or anything, or just check out my website, and you can always contact me from there as well. Thank you so much.